Hi, we're going to go ahead and work on lesson 10.2, similar figures. Now, I briefly talked about this last class, what the word similarity means, and we're going to dig into it more today. All right. Now, similarity, is not to be confused with congruency. Similarity, we have a new symbol, and it's like the top of the congruent symbol. I think it's called a tilde. It's just like a little squiggly. So two figures are similar if they have the same shape, but they have different sizes. So the sides are proportional and the angles are congruent. And again, my analogy always is the photocopier. You blow up a square, you make it bigger or you make it smaller. The sides get bigger or smaller, but the angles still stay those 90 degrees. So when you get confused, think of that analogy and it will help you. Okay, now this is called a similarity statement. Now, first semester we had congruency statements. Now we have similarity statements, and they kind of mean a lot of the same thing. Now, remember how the order matters? The order still matters. So, like angle A is congruent to angle D, angle B is congruent to angle E, and C with F. Now, when you look at the sides, it means the sides are proportional, not congruent like first semester. So as you can see down here, I listed the congruent angles or equal angles. And here we have, this is called an extended proportion because there's more than two things listed. So we know, and you can use this up here, DE is congruent, proportional to AB. It's hard to change my word. EF here is proportional to BC. And then lastly, F to D is proportional to C to A. Now, again, you need to know the definition of similarity. The sides are proportional, the angles are equal. Now, once you make this, now let's just do this real fast. Ignore that bell. Okay, now we don't have to go in this order. If I told you to write a proportion, you could just look at the two triangles and you get to decide like which triangle information you want to go on top. Now, my little trick is I usually go in order, like smallest to greatest. So like if I look at the tiny triangle, I would write 3, 4, 5 across the top. 3, 4, 5. And then for the bigger triangle, I would do the same order because sometimes the pictures are rotated and flipped and it's not real easy to tell what goes with what. And so I would match it up and say 6, 8, 10. Okay, now if you notice, they all simplify to the same number. They all simplify to a half. Now, this is called your scale factor. And for whatever reason, we call it K. Like slope is M, they just made up the scale factor is K. They didn't ask us, I would have made it S, right? We all would have. All right, so K is your scale factor. So really what's happening, they're saying if you take the 8 and you times it by the scale factor, you get the 4. You take the 10 and you get the 5 and so on, you get the idea. Now the thing about scale factors, think about the copier. If your scale factor is 1, which is like 100%, the figure doesn't change. It stays the same. But if your scale factor is more than 1, that means it's getting bigger. It's like if you copy something at more than 100%, it grows. Here, I'll just write grows. So if my scale factor is less than 1, it's going to shrink. So if you have the scale factor of a half, you know that from the first object to the second object, it is shrinking. Now, some of you might be saying, well, what if you started with the other triangle first? And that's a good question. So what if I put 6, 8, 10, and then the 3, 4, nope, it's 3, yeah, it's 3, 4, 5, 4, 5. Well, if you simplify all these, you get a scale factor of 2. Well, scale factor 2 means it's growing. So that means you're starting with the smaller triangle and you're timesing 5 by 2 to get 10. All right, so that's how that all works. All right, so now that we know all of that, let's look here and determine the scale factor. Now, if it doesn't say which way to go, you can go either way. And your textbook is bad about not really saying which way to go. If I write it, I often say from the small figure to the big figure or the big to the small. Okay, now it does say original figure and a large figure. So you're getting bigger. That means your number is going to have to be bigger than 1. Okay, so what is the scale factor? If A, B, C, D is the original figure, then we enlarge it by a scale factor of blank. Now, here's a general thing you can just count on. You take it and you're like getting bigger. So take the second number and that goes on top. And then you simplify it. So the scale factor is 3. Now, if you're going backwards, if you were starting at the 12 and going this way, the 4 would go on top. And then it would be a scale factor of a third, which means it's getting smaller. But that is not the case this time. Again, ignore that bell. Okay, which 2 triangles are similar? Now, your textbook, we all know, I think your textbook's a little wacky sometimes. Everyone that I've ever talked to calls it scale factor. The guy who wrote your book calls it magnitude. Okay, so the words are going to be interchangeable. Okay, now to make this easier, let's call these A, B, and C. Now we have to compare 2 triangles. We just have to guess which 2 do you think are similar? Again, similar means angles are congruent, sides are proportional. Now, we're not going to really be able to test the angles right now. We're just going to test the sides. So let's test, just go in order, A and B. Now let's use my little method of smallest to greatest. So on A, 18, 27, and 33. And on B, smallest to greatest, 24, 36, and 44. Okay, now it's calculator time. Now I only have my cell phone, but it'll work. 18 divided by 24 is 0.75. Now guys, your scale factors have to be 100% the same. If they're off by anything, then you're going to say it doesn't work. And did I pick the right one just by chance? Oh, I did. I wish I wouldn't have, but I did. Okay, so which 2 triangles are similar? Well, guys, I have the same scale factor. I don't know why I put 2 5s. Triangle 1 and triangle 2, or A and B. So these 2. Now, I want to show you one where they're not proportional. Okay, so let's just do A and C real fast. So again, we know A is 18, 27, and 33. And so this is 22, 30, and 40. Okay, so 18 over 22 is 0.818. Repeating. And then 27 over 30 is 0.9. And then the last one is 0.825. As you can see, they're all different. And this was A and C. They're not similar. Okay, but this is the one that worked, A and B. Okay, so again, we're talking about your textbook, okay? They're going to mention the center of dilation. So that is just like when you have your 2 figures, and as they're getting bigger or smaller, they're growing at the same rate. And I probably can't draw this. There. And as you can see, they just keep at the same rate all the way down. And this is like where all the sides meet. That is your center of dilation. They will mention it just so you know what it is. Here it is. All right. Now, This is just a nice, pretty color-coded picture that kind of shows you what similarity means. The corresponding angles have to be congruent. As you can see, not every single angle is 90 degrees, just corresponding angles are congruent. Sides are proportional. And again, this doesn't have to just be triangles, this could be any shape. And this is called your similarity statement. All right. Now, ignore what it says your assignment is because your assignment is going to be different today. It says determine if the figures are similar. If so, write a similarity statement. Okay, so we have to check the side lengths. Now, the angles are pretty easy to check. Now, right away, if the angles don't work, then you're going to say they're not similar. Now, we do have a theorem that says if they have two angles in common, it means the third angle is also in common. And so in regular geometry, this is called the third angle theorem. I know your book doesn't really give it a name, but it's a good name, right? Two angles in common. So for instance, if this is 30 and this is 30, if you take 180 and you subtract 90 and 30, they both come out to the same number. All right, so the angles work. Yes. Are the sides proportional? This is like a checklist. Let's check it. It doesn't matter which triangle you start with. Smallest to greatest. Smallest to greatest. That is a 15 if you can't read my bad handwriting. Let's check the math. 6 over 9 is 0.6 repeating. 8 over 12, 0.6 repeating. 10 over 15, 0.6 repeating. Are the sides proportional? Yes. So let's write a similarity statement. So the first triangle could be in any order you pick. And the second triangle has to be in corresponding order. So that would be M, N, T. All right, are the angles congruent on the second one? Yes, they're all 90, easy. Now, the next one, if you notice, you really only have two different measures. You don't have to list it for like doubles, right? So I know the 10 corresponds with the 8. I know the 6 corresponds with the 4. Let's grab the calculator again. 10 over 8 is 1.25. And 6 over 4 is 1.5. They're not the same at all. So these are not similar. And the last one. Now, again, we could use that third angle theorem. We have two angles in common. We know it works. Are the sides proportional? Well, only one way to tell, guys. You gotta write it out. 6, 8, 12, and 4.5, 6, and 9. Get the calculator again. 6 divided by 4.5 is 1.3 repeating. That is repeating. 8 divided by 6, same thing. 12 divided by 9, same thing. Okay, so are the sides proportional? Yes, they are. So let's write a similarity statement. My goodness. Okay, now this one could be a little tricky because it is rotated and flipped, and so use the angle markings to help you. The L has the two little marks here, so that's going to correspond with a T. The M has one mark, so that's going to correspond with P, and N with O. All right, and that is it for today. Let me know if you guys have any issues or questions.